Welcome to VLSI DFT lecture series. In this lecture series, the subjects we are going to discuss about is VLSI technology and ASIC flow. What the scope of VLSI? Let's start with the discussion with that. VLSI, this is an acronym. Expanded, it actually means very large scale integrated circuits or very large scale integration. So to start with, let's first see what an integrated circuit is. What is a circuit? What comes to your mind? Something like this. A printed circuit board. Different components are soldered in that. Resistors, capacitors, diodes, connecting wires. This is a discrete circuit. It consists of discrete components. In contrast, in an IC, the entire circuitry, that's active and passive elements. By active elements, I mean that bipolar junction transistor or field effect transistors. They can be capacitors, resistors, diodes. Everything is housed on the same substrate. This is a microprocessor called Pentium, developed by Intel. It consists of more than 300 millions of transistors housed in this small chip. So, an integrated circuit or IC is a small chip that can function as an amplifier, oscillator, timer, microprocessor, or even computer memory, and is usually made of silicon that can hold anywhere from hundreds to millions of transistors, resistors, capacitors on it. Depending on the complexity of IC, we called it as SSI, MSI, LSI and VLSI. The first integrated circuits contain only few transistors called small-scale integration. The next step in the development of integrated circuits introduced devices which contain hundreds of transistors on each chip called medium-scale integration, MSI. Further development driven by the MOSFET scaling technology and economic factors led to large-scale integration, LSI. Then VLSI technology, very large-scale integration. It is the process of creating an integrated circuit, IC, by combining billions of transistors into a single chip. The microprocessor is a VLSI device. An electronic circuit might consist of CPU, ROM, RAM, and other glue logics. VLSI lets IC designers add all of these into one single chip. So with the arrival of VLSI designs, the number of possibilities for ICs in control applications, telecommunications, high performance computing, and consumer electronics become high. Microprocessor in PC, laptops, mobile phones, chip in graphics card, digital camera, automatic cars are few applications of VLSI. An SoC, system on chip, is also a type of IC. By Moore's law, the number of transistors on microchip doubles every 2 years. Though the cost of the computer is halved, means IC meets the required functionality with best quality of result in terms of less area, high performance, high speed, low power and low cost. I guess we have gone through the basics of VLSI design technology. Look forward for more details of ASIC design flow and DFT in the next classes.